let us continue our discussion on 12 pulse LCC. Now, we have seen the circuit. I will not try to draw the entire circuit diagram, but what I will do is I will just show that there are two 6 pulse LCCs in addition to two transformers. For example, I can have one Y transform, one Y delta transform. So, there is a 6 pulse LCC. There is another 6 pulse LCC. So, there are 3 wires on the AC side. Of both 6 pulse LCCs, and the DC sides are connected in series. Okay. Now, the voltages that appear on the AC side of the second 6 pulse LCC are identical to the voltages which appear on the AC side of the first 6 pulse LCC, except that there is a phase lag of 30 degrees to the second 6 pulse LCC. Now, accordingly, the instant of gate pulse will be delayed by 30 degrees. Okay. So, with respect to the first 6 pulse LCC to the second 6 pulse LCC, gate pulses are delayed by 30 degrees. Now, you see that if you take any current, suppose I take fundamental current, the fundamental currents that are flowing on the AC side of the second 6 pulse LCC are lagging the fundamental currents of the first 6 pulse LCC. They are equal in magnitude, but lagging by 30 degrees. If you take any harmonic component, it is 30 degree into H. Similarly, on the DC side also, it is if you take any harmonic components, there is a 6th harmonic, 12th harmonic. So, if you take the second 6 pulse LCC, the harmonic component is lagging the corresponding harmonic component of the first 6 pulse LCC by 30 degree into H. Okay. Now, the question is, if I have normal operation, see, normal operation means both the 6 pulse LCCs are having 2 and 3 valve conduction mode. So, normal operation for 6 pulse LCC, both 6 pulse LCCs is 2 and 3 valve conduction mode. Let us assume that both 6 pulse LCCs are having normal operation. Then at any instant, if I take all the 12 valves, so now in the 12 pulse LCC I have 12 valves. At any instant, what is the number of valves that conduct? Assume that the voltages on the AC side of the 12 pulse LCC are balanced, sinusoidal, and the equivalent leakage inductances of the two transformers are equal. See, one point to notice, when I have 2 and 3 valve conduction mode, the value of U is between 0 and 60 degrees. Okay. Now, both 6 pulse LCCs are having 2 and 3 valve conduction mode. That means, if you take any 6 pulse LCC, at any instant either 2 valves are conducting or 3 valves are conducting. Now, if I take together all the 12 valves, there are 12 thyristor valves. At any instant, what is the possible number of valves that conduct?
We will have two cases where U is less than 60 or U is greater than 60.
Just consider, you will say, let us assume.
Less than 30 or greater than 30.
Okay, less than 30, what happens? Okay, let us take, say, if I take the first subinterval of any 6 pulse LCC, it is from alpha to alpha plus U. So, here how many valves conduct? 3 valves. 3 valves conduct. And alpha plus U to alpha plus 60 degrees. two valves conduct. Okay. Now, let us consider different cases. Suppose u is say less than 30, and of course, obviously it is greater than 0, and less than 30. Suppose u is less than 30, then what happens to alpha less than omega ot less than alpha plus u?
For the first one,
Yeah, in total. So, say for the first I have already said 3 valves. Okay, let me try to draw one more diagram. Okay, so suppose this is omega ot. Okay, this is the first 6 pulse LCC. Suppose this is alpha. I also show what are the valves that conduct in the second 6 pulse LCC also. Okay. Suppose this is alpha plus 60 degrees. Alpha plus 120 degrees. Now, let us take the case u less than 30 degrees. Okay. So, suppose this is alpha plus 30 degrees, and since u is less than 30 degrees, I show alpha plus u here. Say alpha plus u is less than alpha plus 30 because u is less than 30. Okay. So, if I take alpha to alpha plus u, what are the valves that conduct? Huh? 1, 2, 3. 1, 2, 3. Alpha plus u to alpha plus 30. In fact, I need not even show up to, separately for alpha plus u to alpha plus 30 and alpha plus 30 to alpha plus 60. I go up to this point. So, alpha plus u to alpha plus 60, 2, 3. Then, now I also show alpha plus 60 degree plus u. So, from alpha plus 60 to alpha plus 60 plus u. What are the valves that conduct? 2, 3, 4. Then alpha plus 60 plus u to alpha plus 120 degrees, it is 3, 4. That is something we have studied. Okay. Okay. Now, I will also number the second 6 pulse LCC thyristor valves as 1, 2, 3. There should be no cause of confusion because I am showing them separately. So, that is why I am showing separately for second 6 pulse LCC. Now, when is the valve 3 of the second 6 pulse LCC turned on? Alpha plus 30. Okay. Then, if I take u, again u will be same for both 6 pulse LCCs. So, if this is alpha plus 30 degrees, this is alpha plus 30 degrees plus u. Okay. So this instant, which I had not shown earlier, is alpha plus 90 degrees. So if I take the duration from alpha plus 30 degrees to alpha plus 30 degrees plus u, what are the valves that conduct in the second 6 pulse LCC? 1, 2, 3. Then from alpha plus 30 plus u to alpha plus 90 degrees, it is 2, 3. Then I also show alpha plus 90 degree plus u. So from alpha plus 90 to alpha plus 90 plus u, valves that conduct are 2, 3, 4. Then after that it is 3, 4. Okay, I think it's better if I slightly change the notation. See, instead of 1, 2, 3 valves, I will use a prime 1 prime, 2 prime, 3 prime for the second 6 pulse LCC. 4 prime is also there. Okay. Now, if I together write the valves that conduct among all the 12, from alpha plus 30 to alpha plus 30 plus u, it is 2, 3, 1 prime, 2 prime, 3 prime. This is from alpha plus 30 to alpha plus 30 plus u. Then if you take alpha plus 30 plus u to alpha plus 60, it is 2, 3, 2 prime, 3 prime. Then if I take alpha plus 60 to alpha plus 60 plus u, 2, 3, 4, 2 prime, 3 prime. Then alpha plus 60 plus u to alpha plus 90 degrees, it is 3, 4, 2 prime, 3 prime, 4 prime. Then alpha plus 90 degree to alpha plus 90 plus u, 3, 4, 2 prime, 3 prime, 4 prime. I made a mistake here. Sorry. So, yeah. So, from alpha plus 60 plus u to alpha plus 90, it is 3, 4, 2 prime, 3 prime. To decide the operating mode, say if you look at even just the 6 pulse LCC, I have to consider, should I consider the entire cycle consisting of 360 degrees? I have to consider? No, in the case of 6 pulse LCC, one interval is sufficient. I just look at one interval that is divided into 2 subintervals, and I just see what is the number of valves in the first subinterval and the second subinterval. So, in the 6 pulse LCC, the interval size was 60 degree. The width of the interval is 60 degrees. Now, in the case of 12 pulse LCC, the width of the interval is 30 degrees. So, I can just look at any 30 degree interval, okay, and see what is the number of valves that conduct. So, you see that though I have shown for more than 30 degrees. Okay. So, at any instant either 4 valves conduct or 5 valves conduct. So, this is known as 4 and 5 valve conduction mode. Okay. Now, this is corresponding to u less than 30 degrees. So, even for normal operation of the 6 pulse LCC, I can have another possibility u greater than 30 degrees. So, what happens if u is greater than 30 degrees? Let us quickly go through that also. Suppose u is greater than 30 degrees. So, let me try to again draw a similar diagram. So, I have this one straight line corresponding to omega OT axis for the first 6 pulse LCC. Now, if u is greater than 30 degrees, alpha plus u is greater than alpha plus 30. So, alpha plus u is shown somewhere here. Okay. So, if I take alpha to alpha plus u, what are the valves that conduct from alpha to alpha plus u? 1, 2, 3. From alpha plus u to alpha plus 60 degrees, it is 2, 3. And again alpha plus u plus 60 degrees is greater than alpha plus 90 and less than alpha plus 120. So, from alpha plus 60 to alpha plus u plus 60 is the first subinterval of the second interval. So, here valves 3, 4 and 5 conduct. Then alpha plus u to alpha plus 120 is the second subinterval of the second interval, valves 4 and 5 conduct. Sorry? Oh, sorry. Yeah, made a mistake. Please correct this. 2, 3, 4 and 3, 4. Now, I will show, in addition to the angles that I have already shown in the first figure for first 6 pulse LCC, alpha plus u plus 30. And also alpha, okay, this may not be necessary, let me check. So, from alpha plus 30, if I take the second 6 pulse LCC, so if I take this interval, so from alpha plus 30 to alpha plus u plus 30, what are the valves that conduct? Yeah, 1 prime, 2 prime, 3 prime. And from alpha plus u plus 30 to alpha plus 90, it is 2 prime, 3 prime. Then beyond this, it is 2 prime, 3 prime, 4 prime. Now, again let us take this duration alpha plus 30 degrees to alpha plus u. So, the valves that conduct are 1, 2, 3 from the first 6 pulse LCC, 1 prime, 2 prime, 3 prime from the second 6 pulse LCC. Then from alpha plus u to alpha plus 60 degrees, it is 2, 3 and 1 prime, 2 prime, 3 prime. Then from alpha plus 60 to alpha plus u plus 30, 2, 3, 4 and 1 prime, 2 prime, 3 prime. And from alpha plus u plus 30 to alpha plus 90, it is 2, 3, 4 and 2 prime, 3 prime. Though it is sufficient to consider only one interval of 30-degree duration for the 12 pulse LCC, I have shown for 2 intervals, that is for 60-degree duration I have shown. So, you see that there are 2 subintervals in each interval. So, in one of the subintervals 6 valves conduct, in the other subinterval 5 valves conduct. Okay. So, this is 5 and 6 valve conduction mode. Now, though I have written u greater than 30 degrees, I am still considering the normal operation. See, one should note that this u is the commutation angle for the 6 pulse LCC. Okay. So, if I go back to this, okay. So, what we are considering is only 2 and 3 valve conduction mode for the two 6 pulse LCCs. We have seen two normal operating modes. There are other operating modes. So, let us summarize all the operating modes. So, let us first see what are the normal operating modes. So, we have already seen two normal operating modes. One is 4 and 5 valve conduction mode. So, this is applicable if u is greater than 0 and less than 30 degrees. We have also seen one more operating mode, that is 5 and 6 valve conduction mode. So, this is applicable if u is greater than 30 degrees and less than 60 degrees. There is a possibility of even 5 valve conduction mode, which is applicable if u is exactly equal to 30 degrees. So, 5 valve conduction mode. Which corresponds to u equal to 30 degrees. So, these are the 3 normal operating modes. Of course, there are other operating modes corresponding to 3 valve conduction mode of the 6 pulse converter or 3 and 4 valve conduction mode of the 6 pulse converters. So, the other operating modes are, so if I have both 6 pulse converters operating in 3 valve conduction mode, then what I get is for the 12 pulse converter 6 valve conduction mode. So, this is applicable if u is 60 degrees. If the 6 pulse converters operate in 3 and 4 valve conduction mode, that is u is greater than 60 and less than 120 degrees, then at any instant we will have either 6 valves conducting and or 7 valves conducting, or it is also possible to have 7 valves conducting at any instant or 8 valves conducting, or it is also possible to have 7 valves conducting at any instant. So, correspondingly we get 6 and 7 valve conduction mode. Seven valve conduction mode and 7 and 8 valve conduction mode. So, these are the other operating modes. So, one can show that if u is equal to 90 degrees, then we get 7 valve conduction mode. Now, similar to the case of 4 and 5 valve conduction mode or 5 and 6 valve conduction mode, we can explain how we get 6 and 7 valve conduction mode or 7 and 8 valve conduction mode. We can also see that we get 6 and 7 valve conduction mode if u is greater than 60 degrees and less than 90 degrees. And it can be shown that we get 7 and 8 valve conduction mode if u is greater than 90 degrees and less than 120 degrees. So, these are the different operating modes.